Hey folks, it's Shane from Performance EV. Happy New Year! Hey folks, well, it's 2020. Thanks for joining us on our first video of the new year. For those of you new to this channel, this is my project to put a Nissan Leaf motor into a Porsche 911. We're kind of at the mechanicals and electrical stage of the project. So in the last few videos, I've been trying to get as many things in place so that we can actually run the motor in the car and potentially even get the wheels turning, which is pretty exciting. So in the last episode we had a bit of an issue where the drive shaft that I had didn't fit. So kind of gave up on that and just started plowing ahead with some of the other tasks that we need to do to get the car running. So one of them was the control panel. A few of you have asked questions in the comments, and this is it's a temporary measure. The plan is that the controls for the inverter will be integrated into the actual Porsche systems, so that there won't be any strange switches or anything like that. But for the moment, because I still haven't even run it, and even once I start running it, I'll be going through a phase of testing and then probably doing some more work and then testing again. I wanted to keep the drive system completely separate from the Porsche systems. I haven't even tried turning on the car yet. I haven't plugged the battery in since I removed the motor, because I know it's going to have a bit of a fit. And I want to be able to continue to do things with the motor and the drive system while figuring out how to make sure that the car itself is happy, and make sure that various warning lights that aren't relevant and are only happening because there's a piece of kit missing, getting those resolved. And this way, with the temporary panel, I can do those in parallel, and I can chop and change between them, and they don't become reliant on each other. So we've got that in place, and I've run some extra wiring back to the inverter to allow me to play around a bit more with the controls. But the plan now is I want to get the inverter pretty much buttoned up. So the signal wiring is in place, but it's not kind of bolted down or anything. It's not properly secured, and then we don't have any high voltage wiring. So today I want to try and get the high voltage wiring sorted and make sure that the inverter is secure and that the wires are properly secured. I don't want to accidentally detach something because I'm trying to connect things that aren't properly bolted down. So yeah, and then of course we do still have the drive shaft issue, which I'm hoping to get resolved. So let's take a look at the drive shaft first, and then we'll plow into getting the wiring done. So first off, an update on where we are with the drive shafts. So the problem we had in the last video was that when I push the drive shaft in here, everything seemed to fit in terms of where the bearing sat on the bearing carrier and all that sort of thing. However, the splines on the shaft that went in here didn't actually make contact with the splines on the output of the differential gears. So I did some digging, and it looks like when moving to this, I guess, second generation stack, Nissan may have gone and changed a few other things other than just the orientation of different parts. It looks like they've changed the diameter of the shafts that go in and out of the gearbox, and I inadvertently ordered a, I guess, 2010 or 2011 shaft for this side, while I got the correct later one for the other side. So I've managed to find a later model shaft, which I've ordered now.
secondhand from eBay. I got them to send me a picture of the end of it, so I was able to check that the spline, the number of splines and everything and the shape of them seem to match what's on the side that does fit. So hopefully that will work. The one area where we might get caught out is with the actual, where it goes into the CV joint. I have no idea if that's changed. So I guess we've got two ways it could work. One, the kind of three-piece part that goes onto the shaft could actually fit the new joint perfectly and will be fine. We might still be lucky, even if that doesn't work, if the actual splines on the drive shaft itself match what's on the inner workings of that CV joint, or at very worst we'll cut the work I did before and start again.
Okay, so we've got a range of different jobs we need to do now, mainly around wiring. So we've got to get a proper cutout made, or proper protective sheet made to bolt in here. So we've got the same ABS plastic that we're using for the switch panel we're going to use for that, so I'll need to cut that out, cut it to shape, and then we're also going to get some wires cut to go from these terminals over to the motor itself. So for the cable from the AC output terminals on the inverter to the AC input in the motor, we've got a large roll of 70 square cable. Probably overkill, but I didn't want to run into any limitations current wise as we try and push this motor to its limits. So this should give us plenty to work with. So we're going to figure out what lengths we need, get them cut to size, and then add some terminals to the end of them. So this stuff weighs a ton and will of course need to be wrapped in plenty of orange tape or ducting to allow us to actually use it in the car and make sure we meet all the relevant laws. Alright, here we've got our cable cut to length, got our lugs. So we're just going to get the cable stripped back and then these crimped on. Alright, that's the wires stripped. Now we need to get the terminals crimped on. So, I mean, you can get different types of terminals for this. You can get solder-in ones. I want to crimp them just because I trust that method. Obviously, something of this size is, normal crimper isn't exactly going to do it. So I need to get a hydraulic one. So here's the crimper, bright yellow box for visibility, so you don't lose it in the garage. If you're going to be doing these size of crimps, you're going to need a specialist tool. These are actually pretty reasonable these days. So this is basically a hydraulic crimping tool. So every push that you do on here, which is nice and easy, essentially a jack in there pushes this slightly closer, and you've got different size dies for different size crimps. And then at the end, you can just release the pressure.
So we need to get the dies for 70mm, 70 square. So that's these ones here. So I'm going to use the curve that's already in these cables. So I want the curve of it running perpendicular to the lug. So I think that could do with a little bit more, so I'm going to drop it down a level, get a slightly smaller die on it, and give it an extra push. So that's the 50 square on it now. That's a much more secure crimp. So we'll get the others done. So there we've got our wires for the 3-phase AC. Now we're going to wrap them in some orange electrical tape, and ultimately they'll go inside some orange conduit, so they'll be identifiable as high voltage cables. But for now we will just make sure that they're not going to short out on anything. There we go, cable's complete and ready to go in the car. So there we have it, the 3 phases of the motor wired up for the first time in probably nearly a year since I took the inverter off the top of them. Alright, let's get them hooked up on the inverter side. And our cable's now attached to the inverter. Longer term I'm going to chop these down and place the holes closer to the inverter itself, just for neatness and to prevent things from getting damaged, but we'll go with this for the moment to test things out. Next step, I want to get this bit buttoned up. So we're using the same ABS plastic that I used for the little panel for the temporary controls, but it's very thin, it's only 2mm thick, so we're probably going to try and sandwich 2 pieces together to create something to replace this. So we've got our plate installed on the inverter. It's good and secure. The amp seal connector is connected to it. Probably doesn't look quite OEM spec, but you know, maybe more track weapon. But it's looking good, and most importantly, with this in place, it'll keep the weather out of the inverter electronics. So I think that's another milestone for me hit. You know, this is the first time that we've properly had the inverter and motor wired together since I took the whole thing apart. Before, I was using dodgy kind of just, you know, frayed ends of cable to try and connect the two. So it's, yeah, great to kind of get these cables built out. As I say, I'll need to get them properly oranged up to make sure they meet the necessary legislation, but they're ready to go now. And then with the inverter buttoned up, I was able to double check the wiring, and I'm happy that nothing has come undone in all the messing around I was doing with the different bits of cable, and now nothing should come undone because it's nice and secure in the inverter. You know, I still need to fully seal everything up with you know, some silicone, but I will do that once we've done a few little test runs with the motor and with the car. So yeah, that's kind of the main part of the wiring sorted. So the next steps around this side of things are going to be to get some of the small lead acid battery modules that I had, get them set up in the engine bay, wired together, and get the pre-charge circuit set up again. But this time I'm going to wire it into the inverter with using the controls that are in place for that. And then of course we've got the drive shaft issue. So I got a package in the post today. I haven't had a chance to open it yet, but I'll do that for the next video, and hopefully we'll be able to get the drive shaft, I guess, stripped down and then rebuilt with the correct CV joint, without having to get the angle grinder and welder out again. But we'll see how that goes. We're getting much closer though to being able to kind of at least drive this car, certainly off the road anyway. I'm not allowed to drive it on the road. It's not taxed, and in order to be able to tax it, I have to get it checked out. And while I think the electrical side of things are going to be fine, there are plenty of mechanical problems that I need to sort out before I'd be able to put it forward for an MOT to get it through that check. That's a little ways down the line. I think first off we want to get it running, and try and just get it moving backwards and forwards. So yeah, that's kind of where we are. I think we're really making good progress, and hopefully in the next few weeks we can get the motor turning. As I said at the start of the video, thanks for watching this. You know, the likes, the comments, even just the views that I see coming up with this are a great motivator and really make me feel like it's worthwhile putting in the extra effort to video this, as well as doing the work to set it up. So yeah, thanks for all that. You know, if you want to
subscribe if you're not already subscribed. Please consider doing so. It helps me get the videos out there. The YouTube algorithms look at that sort of thing, look at that engagement to try and decide how to promote it. So yeah, click the subscribe icon if you fancy subscribing. But till then, thanks for persevering with me over the course of 2019. Hopefully in 2020 we'll be making some good progress, and we'll see you next time.